In this section, we're going to look at a different type of spatial image processing operation. To illustrate this, I'm going to take the Mona Lisa image, and I've chosen a large number of random pixels within the image, and I've set them to either 0 or 1. This is sometimes called speckle noise or salt and pepper noise. The image now is corrupted. It's got a large number of white and black spots on it. One way to try and reduce the effect of this noise would be to compute an average. We've seen before how the averaging operation tends to blur out and reduce fine detail. So if I compute the average of this noise corrupted image, we can see that the intensity of these noise pixels has got less, but they've also tended to get a little bit bigger. They've been smeared out. They're now wider, but they're not as distinct from the background. If I increase the size of the kernel that we use for averaging, we can see that the salt and pepper noise has perhaps almost completely disappeared, but there's been some collateral damage. The image now is quite blurry. So is there a way that we can reduce this salt and pepper noise without removing the fine detail in the image that we want? And indeed there is. The technique's called rank filtering. So to look at how this works, we're going to zoom in on a very small 3x3 patch of the original image. And we see some grey level values here, and they're typically around 120 to 130, the grey level values that should be at this particular region. And we see that one pixel has got a value of 0. This is a noise pixel. If we compute the average over this window, we see that it's got a value of 110. Now this value is a bit lower than the other values that are around here. We probably wouldn't be expecting a value of 110 here. And what's happened is that this value of 0 is so far away from the values that should be here that it's pulled the average down. It's influenced the average. So we want a different sort of statistic, and a statistic like the median value is actually more helpful. So the median value across this 3x3 region would be 123, and that would perhaps be a much better guess at what the value should be at this location. How do we compute the median? Well, the simplest way to compute the median is to take all the values within this 3x3 window and stack them up from the largest through to the smallest. We're going to rank them. And the rank number 1 pixel is the maximum value within this window. Rank 9 is the minimum value within this window. And rank 5 is the median value. And the median value is what we're interested in. So let's apply a median filter to the Mona Lisa image. There she is with the salt and pepper noise. And here she is after we've applied a 3x3 median filter. You can see that the effect of the noise has been dramatically reduced, but the fine detail in the image has been mostly retained. To compute this, we use the toolbox function iRank. The first argument is the input image. In this case, it would be the noise corrupted Mona Lisa. The second argument is a 3x3 matrix of 1s, which indicates the size of the region over which we want to compute the median. And the last argument, 5, is the rank that we want to choose. Because we've asked for median over a 3x3 window, rank 5 is the middle value of the 9 elements within that window.